CIT 225, Computer Security or Network Security and Penetration Testing. Chapter number 6 is talking about encryption and password cracking. We'll try to understand why is it important and why are we covering it. First of all, the objective of the chapter is to understand the cryptographic principles, understand the fundamentals of encryption, describe the most common ciphers in use today, and identify the most common attacks on passwords, use various programs for cracking passwords. Now, encryption and password cracking, strong passwords are a little bit difficult to crack as compared to the easier passwords. Like if someone is having 1 2 3 4 5 6 7 8, first of all, it's very easy to see what you are entering on the computer. Second thing is anyone can crack it from 1 to 8 or 1 to 9. Or if you are keeping a very easy password like ABCD 1 2 3 4, or you are having the first key, first row of the keys on your keyboard, it's again very easy to know what's the password of the computer. Now, guessing or stealing or cracking the password foundation for defeating any kind of security is important, like we can check those things easily. Now, next thing is cryptography algorithm, which encrypts the ciphertext document from a plain text document. Now, algorithm is the way or the technology they are adapting in order to convert a plain text and to convert it into an encryption. First of all, why do we need encryption? Why are we so worried about encryption? The reason is that before, long time ago, like when the technology was evolving, and we saw it in capturing the packets as well, that if a plain text password is flowing on the network, you can easily capture the packets and you can know what's the password exactly. Same was the problem if you were authenticating yourself against any application, and if your passwords were traveling on the network without being encrypted, it means that anyone can capture and the username and passwords can be compromised. So in order to overcome that, they came with the algorithms which helped us in encrypting the password before it leaves or travels on the network. Now, algorithm decrypts the ciphertext back into the plain text. It means that the moment your text is released from the computer and it travels on the network, it's encrypted. It reaches the destination, then it's decrypted again. Transposition changes the position of order of letters or words. It means that it would substitute one word with the another one depending what kind of encryption is it or what kind of algorithm they are talking about. We'll cover it later in the chapter. It does not rely on the length of the password, regardless how long is the password. The way it is encrypting, it depends on the kind of algorithm which is used. Transposition is based on the probabilities. Anyone can break the transposition cipher based on the frequency of letters. So, for example, if a alphabet is appearing for the first time as A, next time, and there is a corresponding value of 1 with that, next time if A would appear, they'll change the number or position of it on 2. So whenever they define any kind of encryption, they must define the way or algorithm to decrypt it as well. Only then you are able to decrypt the things which are encrypted. Now, substitution is replacement of a letter or a group of numbers with another letter or a group of numbers. For example, if you wanted to send a message, as it happened in World War earlier, that they changed the text by the Germans to the ciphertext where the alphabets were replaced one after the another. It means that there were around about, how many alphabets are there in English? 26. How many numbers are there? 10. So total, the combination of alphabets and numbers were 36. It means that a password or a digit could be a combination of alphanumeric anything, probability of 1 to 36 on each thing. Now, Enigma is possibly the most famous substitution cryptography machine used by the German army during the World War II. So they use this technology in order to in order to encrypt the messages, and then we had turning Bombi like a machine of cracking the Enigma code developed by Alan Turing. Now you can see in this picture, this is actually the Enigma machine on your left hand side, where it was used to encrypt the message. Like if you were typing in a letter A, it would change it to something else and it would type it accordingly. If it is received at the other end, they'll key in the same message, so the machine would automatically convert it to the normal plain text. So in order to decrypt that, we had a thing from Alan Turing, we called it Bombi, and it was released after this. As you can see that there are 12 spindles on each line, multiplied by 3, 36. Just I told you that there are 26 characters in alphabets in English and 10 numbers, total 36. So in each line there are 12, and then there are 3 iterations of it. So in that way they ran it on that in order to decrypt the message, whatever was flowing on it. Now the substitution continues. We had a Colossus, there's a programmable computer which was released in 1943 by Max Newman. The common terms they were dealing in a clear text, ciphertext, key, algorithm, and hash. Now if we'll try to understand, a clear text is a normal text that we have in English. Ciphertext is when we convert that English text into a coded language which cannot be understood easily. That's called a ciphertext. A key is an encryption key or a decryption key which is required in order to decrypt the message. An algorithm could be any algorithm that you are using in order to encrypt a message, and hash provides us a hash value of a file for the integrity. Now that's a picture of Colossus programmable computer by Max Newman in 1943, which was used to define different cryptographic algorithms. Now we have symmetric and asymmetric key encryption. Encryption can be performed with either symmetric or asymmetric. Both are different. The only different thing between symmetric and asymmetric is that in symmetric there is one key to encrypt the password and one key to decrypt the password. Now the problem with that was that if, for example, you sent a message encrypted by a key, you need to send the key to the other person by any means so that they can decrypt the message. Now if you send the same key and it's intercepted by the party, they can easily decrypt the message. Sometimes called a secret key algorithm, because you are sharing the secret key. Use the same key to encrypt and decrypt the data. No difference. Whoever got the password, they'll be able to decrypt it. Just like you zip a .rar file with a password, you'll have to send the same password to the other person to unzip the file. It was the same thing to decrypt the message. You need to have the same password exactly in order to decrypt. Sender and recipient must have a copy of the key. Inherent vulnerability of a secret key algorithm is that the key must be transmitted by any means so that the other person can see the message. It's very fast as compared to asymmetric key algorithm because it does not require a lot of computational power. Now these are the different algorithms or ciphertext examples. We have triple DES, then we have EES, then Blowfish and RC4. They are just algorithms. For the sake of information, try to understand is that triple DES is very slow because it deals in the text in blocks. So it would take a block, it would convert it into a ciphertext and then encrypt it, and then it would do it 3 times. So if it's taking a block and doing it over and over again, it means that it would take a lot of time. Then we have AES, which is quite standard, it's very fast, and then Blowfish, which is slow, and RC4, which is very fast. Now the key length depends on the kind of algorithm they are using, but keep in mind that whenever we are talking about symmetric encryption, you must see 3DES, AES, or Blowfish and RC4. Now, stream ciphers use a key stream to encrypt and decrypt the plain text message. For example, a list of random numbers from 1 to 25 key stream is similar to one time pad password. Like they'll take 1 to 25 and total alphabets are 26. So they'll take one, for example, A to Y, instead of Z, they'll add a number to it. And then they'll keep on changing on every table. A number in one time pad is added to the letter in the plain text to encrypt and subtract from the ciphertext to decrypt. Algorithm sorts key stream with the plain text message, and then we have block cipher. Now, block cipher, as I told you, it takes a block and then it converts it. In a block of data, algorithm break into a plain text document into blocks, usually 8 or 16 bytes. Operates on each block independently. Plain text will always be padded, and the block ciphers will allow you to reuse the keys. Now we have a symmetric keys algorithm, also called as a public key algorithm. Two keys are required in order to encrypt and decrypt the data. Each user has a public key and a private key, which we are using these days. For example, again they gave an example in book for Alice and Bob. Now, if Alice would like to encrypt a document, she might require a public key of Bob. So, public key is available to everyone. You can share your public key with anyone. Now, Bob would send his public key by any means, no need to encrypt it or anything, to Alice. Now, Alice would use her private key and Bob public key to encrypt the message. Now, once message is encrypted, if someone would receive it and would try to decrypt it, of course they won't be able to decrypt it because it is encrypted using public key of Bob. So there is a mathematical calculation, it would detect that whether it belongs to the other person or not. Same goes for Alice. If Bob would like to send something in an encrypted message to Alice, he will ask Alice public key. He'll use her public key and his private key to encrypt it. So once he'll receive the message from Alice, he'll read the message by entering his private key and public key of Alice. Each user has a public key and a private key. Public keys can be sent on an encrypted or unsecured media. Anyway, you can send it through emails or anything. And the private key decrypts and encrypts the public key. Now, when we talk about asymmetric key algorithms, you must have Diffie-Hellman, DSS, and RSA. That's all you must have in your mind as far as the certifications is concerned as well. That what are the algorithms for a symmetric key and what are the algorithms for the symmetric key. Now we have DSA, digital signature algorithm. A digital signature connects the documents with the holder of a specific key. It would convert the text to a ciphertext, and then there is a mathematical calculation of a file. It would combine it together to have a message digest, and that verifies the digital signature of a document. Consider too slow for general encryption. Digital timestamp connect the documents with a specific time and origination. Now, one thing that they didn't mention over here is that symmetric key, they mentioned that it's very fast in order to decrypt the message. Asymmetric key requires some computational resources because you'll have to take the public key and private key and then calculate it in order to show the output. For one or two or smaller documents it's fine, but if you are receiving a huge data and you need to decrypt it, it requires some computational power. Now, digital timestamps connect the documents with a specific time of original, and the cryptanalysis or a person who decodes the message to make them readable. First and the most important steps of the cryptanalysis is detecting the key values, that what kind of algorithm is used. Then he'll use the required tools in order to decrypt the messages. Now, symmetric key ciphers are DES, which is a block cipher developed by early 1970s. Just for the sake of information, FIPS approved and uses 56-bit to encrypt and decrypt the message, break the plain text into 64-bit blocks. As I told you that it takes block by block, then it would encrypt the message. can use the same algorithm for encryption and decryption. Then we have security DES, depending upon the chosen key. It's susceptible to brute force attacks. Triple DES encrypt the text in 3 times in DES in different types. As mentioned earlier, almost 3 times slower than DES, and the security of DES is equivalent to single DES of 112-bit keys. An advanced encryption algorithm or a standard is also known as REGENDAL. It's a block cipher adopted by encryption by US government, superseded by DES in 2001, and uses a block size of 128 bits. Input bit sequence is copied to 4x4 arrays and is known as the state array transformation, transformed via a series of substitution transpositions. Now the beauty in that is that it's very fast but slower than Blowfish, which is another algorithm for that. All successful attacks upon AES have been through side channel attacks, meaning using the third party tools or application, are based on the factors other than the strength of the algorithm, so they'll find the weakness of it and would exploit it using that. Now IDEA is an international data encryption algorithm developed by ETH in Switzerland, uses 128-bit key, operates on 64-bit blocks, uses a series of identical operations applied, and then speed of IDEA is somewhere faster than triple DES but slower than DES. Security of IDEA resistant to different cryptanalysis, and some weak keys are known. Now we have for the symmetric key, we call it skipjack, which is an assay developed by encryption algorithm that was developed used in the Clipper chip. Uses an 80-bit key size to operate 64-bit blocks, partially vulnerable to different cryptanalysis. And then we have RC4, which is still successful, designed by RSA, Data Security Incorporation. Main benefit is its speed and can be useful where moderate security is needed. It's a mostly public, and then it was invented in 1977. It's based on the fact that it's difficult factor to large numbers, and some progress has been made in factoring the large digits. Now we have Diffie-Hellman allows 2 parties who do not have prior knowledge of each other to establish a secret key over a public or insecure channel. DSS, digital signature standards, are based on the digital signature algorithm based on the general digital signatures for authentication of electronic documents. So whatever we are sending online, we need to verify that the document has been sent by a person before it's authenticated, and making sure that no one has modified the information in that. That's why digital documents and digital signatures are very powerful and used in all common applications these days. You can encrypt a document and have a digital signature of it in Word, Excel, yani Microsoft Suite, as well as in the PDF readers, Adobe Acrobat Reader, Nitro, Foxit, all major companies. You can have a digital signature of it. Combination of a public key and a cryptography and a hash function. Now elliptic curve crypto systems is a curve are harder to solve than the factoring the products on the larger prime. Its curves are used for cryptography, are mainly defined over the finite fields, and then the Neo for Java uses a matrix of 251 8-bit numbers set to equivalent of RSA 1024. Now the lattice-based crypto systems based on NP complete problem involving the geometric shapes but built of lines or vectors. Lattice-based systems have not proven to be effective for cryptography. Now there are different hash functions which are based on cryptography to transform the variability of the length of the fixed length of the hash. Hashes are often referred to as the digital fingerprints of any document, file, folder, partition, or anything that you want to get the hash value of it. The Message Digest 5 MD5 secure algorithm developed in 1992 operates in input of 512-bit blocks and produces 128-bit hash value. Now we have SHA, and it was then advanced version of it is SHA-1, was developed by US government and adapted as FIPS standard. Several variations are there since that time. SHA-1 hashes are 160 bits long, and SHA-2 produces larger hashes for bigger files and for enhanced hashing value of the files. If you remember, we used these algorithms in our previous course where we were covering about computer forensics and investigation. We tried to find out the hash values of the files and folders, and there are different tools to do that. Attacks on passwords. Password protection is open to many kind of attacks, from dictionary attacks to sheer guesswork. Most of the guys who try to claim that they are hacking, sometimes or most of the time they are trying to guess the password. Now, dictionary attack is guessing the passwords by using a list of common words, usually the words which are available in the dictionary. By uppercase, lowercase, they make a list of it and try different passwords in order to guess that what's the actual password. Can determine the key necessary to decrypt any encrypted document. That's for symmetric, because in symmetric encryption you have only one key to encrypt and decrypt. Usually do not work against complex passwords, and crackers need the file that contains the password of the target, and then the defense to limit the number of guesses allowed before the user is locked out. Just like in Active Directory, we have a threshold of for example 3 or 5 or 10, depending what kind of setup you have. You can deny the access or lock out the account if there are 3, 5 or 10, depending on your setup, unsuccessful tries. It would simply disable or lock out the account. Now, hybridization attacks are guessing the passwords by creating new words. The words which are available in the dictionary with minor modifications, they'll create a list of it, which could be the possible passwords. Add a letter or a number to every word in a dictionary. Some hybridization method use a number of spread, for example, insert number into the passwords. So it would be alphanumeric. Duplication, duplicating a word to form a new word, or by substituting with symbols, replacing letters with numbers and symbols that look similar to the missing letters. For example, people enter, instead of S, they enter $, or instead of O, they enter 0. Now, there are different examples. For example, appending characters means that adding endings such as ing or for you to the words in the dictionary. For example, the word is Alfred plus for you is equal to Alfred for you. They'll change it like that. Or reversing the words for reversing the letters in words in the opposite direction. Duplication of the word, creating a new word by repeating the same word. Now, in most of the directories, if the username is appearing in the password, it won't accept it, especially in Active Directory. Number spread, inserting the numbers into the password, so they can add any numbers in the password. Now, the guidelines to protect against dictionary and hybridization attacks are: avoid using the same password for everything. Don't have a same password for your email, Gmail, official email account, your computer, and all those things, because if one password is compromised, anyone who has the password will be able to log into any of the services associated with that, especially Facebook and stuff. But now, if they'll detect that you are using a different computer and you are trying to log in using a new computer, it would send an authentication code or it would ask for verification. Avoid using one's own name in a password. It's in the Active Directory. If your name or your username or your actual name is appearing in the password, it won't accept it. Avoid using common word names for passwords. Very common names which are name of brands or organizations or products, anything which is quite known in the industry, it's preferred not to have the passwords related to them. Include random letters, numbers, and characters, and avoid writing down difficult passwords where they can easily be found. Just like people have it on pasted notes in front of them in their offices, because They cannot memorize the passwords. Now, brute force attacks, usually all possible combination of letters and numbers and special characters to determine the target password. Now, brute force works usually on offline mode, because if online mode someone would be trying a different combination of passwords, it won't let it run and it would lock out the account after a couple of tries. So very time consuming and requires patience, because it would try all combination of passwords with alphabets and numbers, and usually GPUs are used in order to guess the passwords. Now, slow compared to dictionary attacks, and need a large number of RAM and fast processor, and most effective when encrypted document or password hash file is there, because then it would compare the hash of the password to the possible hashes that they have. Can be extracted from the target system and tested on an anonymous offline location, because if online, as I told you, they'll do it, it would be locked out. Now, observations is, for example, snooping, eavesdropping, or shoulder sniffing, used whenever an attacker has a physical proximity, who is looking at you, or he has access to your machine where you are entering the password. They are keeping an eye on that what kind of password you're choosing, and can literally watch the victim type in their username and password. Now, Keyloggers records every key pressed on a target computer, can easily be installed on any computer, and usually it's not detected by antivirus. Keyloggers are generally invisible to victim. Now, social engineering, crackers can pretend to be legitimate user of the target system and extract information simply by asking people behave naively when a so-called computer expert questions them. What kind of password do you have? What's the secret question? Did you set up your secret answer? Just make sure that if you forget your password, you note it down somewhere so that later they can get access to it. Another form of social engineering. And then crackers use packet sniffing tools to catch clear passwords from protocols such as Telnet, FTP, or POP3, where the passwords are flowing on the network in a clear text format, and they can easily copy it from there. Now, password files stealing is, cracker can steal or copy the files where the password hashes are stored, just like in Windows. From the victim's computer, cracker can take all the time necessary to perform a brute force attack. Sometimes passwords are not stored in the main system, but in a shadow file, readable only by the users with administrative privileges. Now, in order to crack these passwords on Windows, or to reset the password, we have password reset disks coming in the form of USB, bootable USB, or bootable DVD. So you'll boot your computer with bootable USB or bootable DVD. It would go in its pre-Windows environment, and then you'll be able to reset the password. It won't tell you what was the actual password, but you will be able to reset the password using tools like that. Now, password crackers, some widely used cracker programs are Cain and Abel. We covered it before. Crack, John the Ripper, Telnet Crack, and TLC Hydra, and Lopet Crack. Lots of them are there these days. Every other day there are new applications or tools available which are exploiting the vulnerabilities found in the systems. Now, Crack by Alec Muffet, designed by Crack for Unix-based systems to guess the known passwords which were there in Linux. I'm sure they might have all the protections against it now. Scan the Unix password for files when extract the weak login passwords, and then it can also detect the encrypted ciphertext by using the Crypt3 algorithm. John the Ripper, a fast password cracker, currently available for many Unix and Windows-based systems, primarily used to detect the weak Unix passwords, can edit the dictionary, etc. And that brings us to the end of the chapter.